Hey guys, here's the number 4 from the ideal projectile motion. I'm going to go over how this cannonball works. So it says cannonball is fired across a field, flat field at an angle 45 degrees with an initial speed of 103 feet per second and an initial height of 31 feet. So first we have to write a set of parametric equations for the motion of the cannonball. That's just like 1 through 3, so I'm going to assume that you can do that. And I'm going to show you what it looks like in Desmos. So if you graph it in Desmos, the blue one is the vertical, which is why it looks like the path, because it's showing how the cannonball is going up in the air, and then the red is the x function, and that is more horizontal because it's going, it's going forward from its starting point. So if you were to graph this, the way that you would graph it is how we had done it previously, where you would use t as the element, or the parameter. And then from times, I did like 0 to 4, and you could plug in t for your x function and your y function, and then you would graph 0, 31, and then 36, 63. And so that's how they got this graph right here. And then it ends around 350. Which I guess I maybe should do one more. Yeah, like right, it ends between 4.5 and 5 seconds. Which, if you notice right here, this is t equals 4, so that's how you'd graph it. And then it says, part 2, determine how long the cannonball was in the air. Well, I'm gonna hide this because I don't want to see these on the graph. But if you look at this, so we've got this blue one and the red one. These are our parametric equations. Where they intersect is the ending point, like where the cannonball drops. So 4.919 seconds is where, or 4.92. Okay, that's where, how long it was in the air. Part 3, determine how far the cannonball traveled in the air. Well, 4.92 is how long it was in the air, and if we want to know how long it traveled, the answer we get is like 359. If I type in 4.92, oops, in our time for our x, that will tell me how far it traveled, because I know that it landed at after 4.92 seconds, and then how far it traveled in the air that's the horizontal distance. So if I plug 4.92 into the x, I get this like 359. That indicates to me how far it traveled. So I'm gonna hide that again. Part 4, determine when the cannonball reached its maximum height. So just like a parabola, the maximum height is going to be right here. So it says 2.264. That's what they have, 2.26. That's when it reached its maximum height. That's because, remember, it's tx, so t is the time, the first ordered pair, and then determine the maximum height. Well, that's going to be this value, 113.445 feet. So that's how you do number 4. Anyway, that's all. Okay, thanks, bye.